Hello and welcome to part 2 of this Elpico amplifier, this AC55 as it is. So we're going to completely restore this amplifier, but I've had a word with a customer, and as we saw on the schematic, this circuit is not very guitar friendly really, so I thought while we're working on this amp we might as well just modify these channels slightly for guitar. So that's what we're going to do. Remember, we've only got 22k plate resistors on these channels, so we're going to be looking at upping those to 100. It's just a few general changes really. So you can see this board's in a bit of a state, really is in a bit of a state, and it took a while to just strip this out. You see we've got a lowly 1 meg resistor on there. Board doesn't look too bad on the back, but very grubby on there. Some of these components don't look very clever at all. We've got this capacitor here which we need to look at, which I think is spilling a bit of gumption onto this board, or has been. So what we're going to do is we're going to gradually replace these components as we go across, and we're going to clean this board as we go. That's probably the best thing while we're in here. Get rid of a lot of these carbon comps that, you know, they'll be noisy, they're out of value, a lot of them out of tolerance. So the best thing to do is just, it's easy just to gut this and just go for it, just get it all done. So that's what we're going to do. Right, so there we go. So we've restored this, and we have made a few changes, so we'll just have a bit of a look. So if we start here, we had a 1k cathode resistor, we've now got a 1.5. We've got a 22 nanofarad, sorry, we've got a 22 microfarad instead of 50 microfarad. The plate resistors were only 22k for mic 1 and mic 2, which obviously there's going to be a lack of gain there, so we've increased those to 100. 22 nanofarad caps, they were 100. Mixed resistors have just been replaced, but they've remained the same. Capacitors have been changed. We've got two 22s there now at 350 volts working. In fact, I think they're 450 volts working, those, but anyway, they're enough for this job. We've not got two 22s, we've got a 22 and a 47 here on mic 2. The cathode is shared. Cathode resistor and bypass cap are shared on both mic 1 and mic 2, so just to get a slight variation in channels, we've just put in a 47 in there instead of a 22. So moving on down here, not much has changed. Here we had a 220k, well, it said 120 on the schematic that I've got, but the resistor was 220k, but we've changed that to 100, and then we've just we've replaced, that was already a 22. Most of these are about the same that we've done here. We've got bypass cap there on this one of these stages. I think it's this last stage. We've got 2.2k, that's what we had before, but again we've changed that to 22 from 50, because we don't want this to be too farty through that small speaker. It's not a huge speaker, and it's probably not a brilliant quality one. So that's pretty much done. So I've changed everything on this board except for these caps here, which I've seen no voltage because they're decoupled, so we're going to leave those in and see how we go with those. I don't think there'll be a problem with them. All the other caps, the hunts and things, some of them just fell apart, some of the resistors were crumbly, and it was just a mess. Everything in this amp was just decayed. I mean, these amps are really old. So now that's like brand new. So now we're going to move on to this part of the amp, which is the power amp section. So we're going to completely gut all of this as well, and again make some changes. We've got these 200 nanofarads, we'll probably reduce those. We've got a cap here that I partially cut out, and then it dropped out. That's 16 microfarad, but we'll increase that. 350 volt working. Again, all these little Hunts capacitors, these plesses will be done as well. Measured the resistor, the cathode resistor, that's good, so we're going to leave that cathode resistor in there. We've got another resistor there, can't see the value, it's a wire wound, so we may well leave that as well. We've got this big can cap on the bottom here. Just going to go in and have a look. Still got this tremolo connected. I ought to unplug it really. We'll have to unplug it before. I don't think we can we? No, it's hardwired in. Or is it? Is that a plug? Oh, it's a plug. Oh, that's great. We can then get that out. And then we've got a plug here. So that's the trem unit there. We can see. So now we've got this trem unit free, so we can have a look at that. And we're going to crack that open. Right, so let's have a look at the top here then. So we've got 50 plus 50 at 350 working volts, so we can replace that easily enough, but we might just have to put a clamp on there, and I think we will, and then we'll just put in a 50 plus 50. We've got some of those. We'll take the tubes out now because obviously we don't want to be damaging those while we're working on it. Got the voltage selector you can see on there. Let's just check that as well. Yeah, that's set correctly. The tube sockets don't look bad. Nice output transformer. So yeah, this should be a pretty good amp when it's all sorted out. Right, so we'll crack on with this, and we'll have a look at it when it's finished. Right, let's just have a look where we've got to with this amp. So we've changed all the components we need to change in here, and we've kept this is just on the negative feedback, so it's seeing no voltage, so we've kept that, and it tests okay. So what's left to do now is this, because I don't like wires just going through holes and being knotted like this one has been here. So we've put one of those cords glands to get the cable, nip it up there and keep it tight, so that's much more safe. Switches on the negative side, so we need to look at the wiring of this coming in from the wall and the switch. And the other thing we need to look at is this capacitor here. We need to change this. So to do that, we're going to have to put a clamp on this chassis to fit the can cap. Right, more or less got this finished. There has been a few things I've had to sort out safety wise. So let's just have a look at those. So the first thing is, if you're going to work on one of these and you're going to change this cap, a few things you need to watch with this. So remember, the cap was riveted in on a Bakelite plate. I've actually put a clamp on there, and if we look, you can see that clamp there on there. So but these terminals on this capacitor, they stick up a lot higher than the others did. Make sure that you put this cap with the lives, the two halves, the live halves, away from this. The reason is that, and I've insulated the ground under there. Now you could still get problems from here, but obviously not with that higher voltage. But what I've done is insulated that, and the reason is that if someone pushes down on that while they're testing, looking for a dry joint or something, it'll make a connection. So I've actually insulated that anyway, but it's best not to have these. I mean, you could add the other two around there and insulated them, but you best keep them away. So that's one thing to bear in mind with this amp, and I have still got to get the heat gun on that and shrink it. But now the other thing is, this amp had no fuses in it, no mains fuse, and had no HT fuse. So this amp was totally reliant upon the fuse in the plug, and let's face it, judging by our collection of 13 amp fuses, that would be the last thing you want in this amp. So there was already some holes here anyway, so I've just utilised one of those holes, and I am hoping that this fuse holder on the side here will fit when I slide the chassis in. I hope so, because I'd have to put it all back together to check, and that'll just be a nightmare. So I've done a bit of a gamble on that one. It should do, but anyway, the switch, sorry, was wired on the negative side. It's now on the live side, and all we've got to do is connect the switch to there and to here, there where the transformer, it goes into the transformer there. The feed is there for the live. You can see we've got the live. We've put a new cable in it. I was going to use the old cable, but in the end just couldn't. It's just you know, this cable is 60 years old. No, I just can't. The more I start these things, and then the safety thing just gets me. Sometimes you just have to do it right. So, and again, we've put this cable gland in there. Again, there were just a knot tied in it, and no, we can't have that. So we've put a new cable in there, and we've tried to get this up to as close as modern standards as we can. So we've removed that 125 ohm resistor, and I've put this fuse in place of it, because I couldn't see why we'd have that in there, other than we've got too much HT voltage on the transformer. But given the fact that this has got EL84s in it, most people push them quite a bit anyway, I can't see that being a problem. So I've removed that. In actual fact, on the Mark II schematic, which I'm using, it's 250 ohms that's on here. So a lot of things different in this amp. So we've got a fuse in there now. We've got that safe. That's what we've focused on, is getting this amplifier safe. This is now ready to be tested. The next thing we've got to do is take that tremolo apart, that little tremolo module apart, which works okay, but of course that switch is extremely noisy on it. So that's the next thing we need to do, and we may have to change some capacitors and so on inside that as well, more than likely. So get that straight. So yep, that's where we are with this one at the minute. So we at least now we've got a decent flex on it. We've got mains fuse, HT fuse. We've changed all the components. Some of those resistors were just rotten as July pears, and the capacitors were all cracked and leaky, and so this amp's like, you know, all the components have been changed, with the exception of the 390 picofarad on this negative feedback circuit, which is a little odd, but I've stuck with it for the time being. We can always go in and change that should it be, you know, a problem. We're just going to run this up now without the preamp part, which is here. So we're going to run this amp up on the current limiter, just this power amp. This Pinnacle tube that came out is suffering from a severe attack of "it's all over, madam." It's got no emissions, so we've stuck another tube in. I'm feeding the signal generator in on just through the going into the phase inverter there, and I've got a little speaker on it just so I can kind of hear what's going on. Right, so we don't have the switch connected, so what we're going to do is this. Don't try this at home unless you know what you're doing. And there we go. So the bulb's just lit, and we've just put 130. Bulb's going dim, that's good. So we've just got 160 volts going into it now, and that should begin to drop. And there we go. Pretty quick. So I've dropped down to 123 volts now because the tubes are conducting. Sounds pretty good. Looks good on the scope. Just have a quick scan across there so you can see the wave that we've got. We can't control the volume. Well, we can control the wave gen volume on the scope, but we can't, obviously we can't control it on the amp because we don't have the preamp connected. But that seems to be working okay. So let's get another probe. Right, so I've got channel 1 on one side of the phase inverter, and I've got channel 2 on the other. You can see there. So let's invert channel 2. So they look pretty well matched to me. Pretty well matched. So all's looking good there. Right, let's take some voltage readings and see what that's all like. That looks very good to me, that does. It's a nice signal, very well matched. Right, so we've got the meter there, you can see. Just sat him in there. There. So we've got 209 on there, but remember we've only got 128 volts on the going into this amp at the moment. We've not got a lot of voltage going in. Now this amp has got an ultralinear output transformer on it, and I didn't notice that on the schematic until I thought to myself, this has got no screen resistors on the output tubes. And then when I started tracing the wiring back, I realised it was an ultralinear transformer. So we've got 211 on the screen, grid 2, and I've got 211 on the plate of the tube, so that all looks good as well on that side. Let's try this side. Yep. Yep, a little bit down on that one, only a couple of volts. So those windings all look good as well. Right, so what I'm going to do now, I'm going to put another bulb in, so now we'll have 80 watts of bulbs. We've let those capacitors cook at that low voltage, so now we're going to increase it. So now we've got 80 watts. What is happening now? We've got 167 volts. And we're drawing 180 milliamps. So that's all still looking good. The resistor's pretty cool. But we're not exactly driving this amp, so... Right, let's check some voltages again. What have we got on the plate now? 246 now, so that's looking pretty good. What we got on this capacitor here, we have 221. That's good. Just check this. 247. 244. So that's all looking good. That's all looking very good. Drawing 180 milliamps. But we've still only got 160 volts going into this amp at the moment. But that's fine. As I say, we're bringing these caps up steady. We're also going to have to do this again when we plug this preamp in. Get this preamp wired back in because of the caps on there as well. And they're only 350 working volts, so we'll have to be. We don't want to be, although they won't be getting as much voltage as these because just dropping resistors will have stepped it down. But even so, we want to be a bit careful with those. Now we've still got this to sort out, this tremolo thingy Medusa. So we need to open this up and have a look inside and see what's inside it. Will there be some components that want changing? Probably will. All the capacitors in this amplifier were shot, more or less, and one of the reasons probably why that output tube is absolutely tired. I think it scored about 20 on the tube tester, which is obviously bad. It's probably because the coupling cap was leaking, and it's obviously just the DC's got on the grid of the tube and just worn it out. Really, it's just made it tired, as it does if you don't, if you've got excessive grid voltage leaking onto the tubes, then it shortens the life of them considerably. Right, shall we go up a bit more then? Right, we've got 140 watts of current limiting now. We've got 195.5 volts, and we're doing 240 milliamps of current there. You can see. Now what I'm doing here is I'm running this up on this current limiter, and yeah, this amp's kind of running okay now. It would be quite easy just to switch it off, that current limiter. But these components are all new, and each time we increase the wattage of the bulbs, we're increasing the current on this unit. So the idea of bringing this up steady like this is if any of these, because these new components do fail, so if any of these components fail, these capacitors for example, these big caps, can cap, if they fail or they should go short, the current limiter will save the transformers, although the fuses will probably blow. But that's beside the point really. We need to keep this on the current limiter while we're testing. So let's have a look what plate voltage we've got now. We're now up to 298 volts, so we're probably going to get about 325, 330. So we remove that 125 ohm resistor. We didn't really need it, and we've put that fuse in place of it. That resistor has actually been changed before, and it's also actually burnt out, because if you look, we'll look a bit closer in a bit, but it's all black underneath that resistor on the chassis. Didn't notice that straight away. I was that busy looking at everything else. It only when I was making sure everything was clean in there I spotted it. So that's probably why there's a 125 ohms in there instead of a 250, because the 250 is burnt up. So there's always been a short on this, and of course there's no fuses in it, is there? And if they've got a 13 amp fuse in the plug, well then I'm afraid that's not going to blow. In fact, this is the plug off it here. Let's just have a look what is in it. Oh, it's only got a 3 in this time, but it probably had a 13 in there before, and that's probably what, that's probably why that blew. And that resistor obviously burnt it up. So, but we've obviously now got we've got an HT fuse, and we've got a power fuse in there, and we'll obviously put a 3 amp fuse in the plug, or we can put a 2 amp fuse in it actually. So that's all looking good. It's all looking very good. So now I'm going to put in 200 watts of current limiting, and now that voltage is coming up. It's gone up to 212. Yep, there we go. So even though the voltage is up quite high now, and obviously the bulbs aren't doing as much limiting, should a short suddenly appear on this, those bulbs will spring into action and absorb it, even though There's now 200 watts of it. And we've now got 328 volts on these tubes at 212. And we're drawing 280 milliamps. Now remember that we're not yet running the preamp on this, so it would be foolish to try and check the bias on this now, because of course what will happen is when we wire up the preamp section, that voltage will drop even more, because for a start we'll have 4 more triodes, because remember there's 2 triodes in a 12AX7, so we'll have 4 more triodes there running, and they will drop that voltage even more. So that voltage will be a little high while we're doing this, because we're missing 2 tubes. And then of course there's all the circuitry that goes with those tubes once they're conducting on that preamp board. So 328. So let's just flick off the current limiter, and we're now up to 238 volts, and we've got 375 on those tubes, which is pretty high, so we'll just drop that down. And that's because we've not got those other tubes running on the preamp board. And of course this tremolo unit as well, we don't know whether there's actually a tube inside this or not, so we need to open this up really and have a look inside and see what we're dealing with. So there we go, that's all looking good. Everything's running correctly. Now one other important thing on this amp is this amp has a split chassis, so we need to make sure that and this part of the amp here, which has the switch on, you can see this is the faceplate and everything, that is deemed as a different chassis. It's in other words, it's not physically touching this chassis, which means we need a good ground to that. And it's very important that if you're working on these amps where you've got 2 chassis, you need to make sure that there's a very solid ground on this second chassis here. So that's something we need to look at, and we need to check that through here. Now ideally, when I've done amps in the past with second chassis like that, 2 chassis, I've put a ground, a proper ground, from the chassis to the second chassis, and obviously I've bolted it both sides on each of the chassis. We should have a ground going through these wires which are coming out of here, which go to the preamp. One of those will be a ground, but we need to make sure that's a good ground and it's not going to fail. So that's something to bear in mind. The biggest problem is that if there is no ground on that chassis and you're holding it and you somehow touch this chassis, you'll become the ground between that chassis, the preamp chassis, and the power amp chassis, and that is not good. So we need to make damn sure that there's a good ground on there. Also on this unit as well, again, it's metal. It's a separate chassis. It's still a chassis, a very small one. It's a separate chassis from this. We need to make sure that this is also grounded. The reason for that is that if you're leaning over the back of this, you've got your guitar around your neck on its strap, you've got your hands around the strings, you're leaning over the back. Instead of going for the knob, you end up touching the chassis. Then you've made a ground between this, and that's gone through the preamp ground and gone into the, in other words, you've made a connection to ground. So we need to make sure this is grounded as well. Grounds are very important, and for safety reasons. Is this on here, is this the only ground that's on this plug that it relies on? If so, then if that's just the only ground on it, then that's not a very good safety ground, is it really? So we're hoping that one of these pins is ground on here. When we plug these in, we need to make sure that they're really clean. So you know, you get a soft wire brush on these and clean them so they're really clean, so when they go into those sockets we get a very good connection. Right, we've got this preamp board wired up, and this tremolo unit that we've still got to look inside actually makes the connection to this stage here. So we've got this preamp board plugged in, wired in, tacked in, whatever. Got this wire here, and this is going to the grid on the phase inverter, and this tremolo unit actually goes between this point here and the grid of the phase inverter. So this board won't work unless you put a cable in and feed this straight into the grid. We'll fire it up just on the current limiter. So just start with 40-watt bulb, and if we go in to there, now I've just got this on a little speaker for the time being, and I'm just going to put this wave gen on, which is here, but we're going to take that off. You can see we're up and running now. All a bit noisy, but that's understandable given all these wires everywhere. And set up again. Right, so you can just about hear the wave gen going through that. It isn't very loud. So everything looks right. Let's increase the bulbs. So now we're up to 80 watts. So let's just go down the line. Right, so that's going into the stage, the gram stage there, so we have a bit more input in. There we go. Just suddenly realised they're grounded because there's nothing plugged into them. There we go. I always get there in the end. So these pots just need a bit more of a clean. So that's all good. So we've got signal there. Now, let's just look at some voltages and see what voltages we've got. So we've got 284 volts on there, 285, but that's to ground, not to cathode. Remember, this amp's cathode biased. So all is looking good. Let's just So we've got 200 volts, 200 watts of current limiting now. 200 watts of current limiting. So let's see what we've got now. 319 volts. Now there's a problem developing here in that although we've added this preamp section to this plate voltage hasn't gone down any. So now if I switch this off the current limiter, you can see we've got 369 volts there, pushing 370 and still going up. Flick the current limiter back on. So you can see on here it says 365 volts there. So this has got a very, very high HT voltage on these tubes. And that's presenting a bit of a problem, and it's why they had that resistor in there, that which was originally 250 ohms at 10 watts, and the one I took out was 125 ohms at 5 watts. And I needed the connections for the inline fuse, which is why I've removed that. And you can see that the previous one had obviously let cotter and had exploded all over the board. So we need to reduce that plate voltage, because I can bet that the bias on this is going to be too high. And we're just going to have a quick look at that bias now. Let's just turn that down. So we've got that. So if we just go in, so there's the bias resistor there. So if we go in, we've got 10.77 there. We know the resistor's 130 ohms. So 82 milliamps divided by 2 is 41 milliamps. Oh, I've still got the current limiter on. That's right, I need to turn it off again, don't I? I switched it back on just because that voltage was so high. Let me just switch it off while we measure, then we'll flick it back in, because I don't want to be running these tubes at that voltage for too long. Right, where are we? 12.883, we'll call that 12.8. Right, just flick that back on a minute. 12.8 divided by 130, that's 98.4 milliamps. Divide that by 2, so that's 49 per tube. Even if we take 5% off for the screens, that's quite high. So I can tell you that we're looking in the region of 14 watts. The biostat, I can just tell you by that, even just doing that basic arithmetic there. So we're looking at, we're over biased by a couple of watts on these tubes. We need to reduce that voltage. But the problem comes with this, it's like chasing a snake. So you reduce the bias to get the dissipation down to 12 watts, and you increase the plate voltage further. So we need to come up with a way of trying to reduce some voltage. So let's just look at that voltage again. We'll just flick back off the current limiter on there, and 367 volts we've got. Now that's plate to ground, of course. So plate to cathode, if we go there, it's 355, that just clicked up. So 355 volts we've got there, plate to cathode. Flick that back on. So let's just tattle down, and we'll just unplug it. Don't try that at home. I always put it on with my fingers when I start it, but not when I take it off, because obviously there's current being drawn there. There's less cut when you first drop it on there. There's little or no current, because the tubes have not warmed up. So shouldn't really do things like that, but sometimes you do when you're working. Right, so this is what I propose to try and solve that problem. The first thing I'm going to try in there, I'm going to remove that EZ81 when things have cooled down a little, and I'm going to put an EZ80 in there and see if we can reduce that plate voltage. Right, we've put a nice Mullard EZ80 in there, so we're going to just pop this on again, and off we go. Still on the current limiter, but we've got 200 watts of bulbs in now. We know we don't need to be taking as much precaution with that as we did before, because we know everything's running pretty good. Right, so we're up and running. So let's flick off this current limiter now. Now with this EZ80, and let's just see how much voltage we've got. Let's just have a look. $344 now we've got. If we just bring the meter up, you can just about see the meter in there. So we had 367 before. Now we've got 343, 344. So that's a considerable drop of voltage. We've dropped 23 volts there. So let's have a look what we've got plate to cathode. Cathode. There. 331 plate to cathode. This to me is just a more sensible way of reducing this voltage than, you know, putting resistors in that are getting hot. To me, when you finish up with that amount of plate volts on an amplifier and you've got the bias way over on the tubes, you've chosen the wrong transformer. But what do I know? So let's just check again now on this bias. So now I've got 11.89. Call that 11.9. We've got 130R. 14.2. Even with that, still 14.2. Even with that, so that's we probably had more than that with the EZ81 in there, but at least that's reduced some of the voltage on the tubes to a more reasonable level. But we still have this problem with the bias being high. I mean, people have run EL84s hotter than that, but they are over. So we know this board appears to be working pretty well, this preamp board. We've reduced the plate voltage, which is good, certainly from the life of the tubes there, because having a high bias is one thing, having a high bias and a high plate voltage is another. Remember on the data sheet, an EL84 is only rated at 300 volts plate and screen, and whilst most people run them over that, we have, at least now we've reduced that voltage. It's not excessively high, and that's not a problem. It's just now that the bias is a little more of a problem. Right, so I've got the preamp all back together, and I've got the amp up and running again. So I've had a chat with the customer, and we're going to change these output tubes. Now these are CV4043, which I think is a military version of a BW6, I think is the number. We'll have a look at the data sheet for these. Now these tubes will stand a good 350 volts on the plates and 310 volts on the screens. So we're going to add some screen resistors to this anyway. These tubes also have a dissipation max of 13.2 watts, which, so what we're going to look at is, and we're only at about 14 watts, so we're only 0.8, so we could adjust that resistor slightly, and the idea is we're going to balance this amp up to run on these tubes. These will last for years and years, the great tube. These are actually primers. So that's the next job. Now we've also opened up this tremolo unit, and I'm just going to switch this off before I start dangling these wires over it, over this. So the reason I'm doing this is because I've got the wires, I haven't got a plug on this amp, and the reason I haven't got a plug on it is because I've got to thread it all through the cabinet, and I'll have to take it off again and put it on. So I'm just leaving it off and just using that, and obviously we haven't got the switch in there anyway. So I'm not pulling it out the wall because I've not got a plug on it, I've just got it connected. So I'm leaving it connected to save messing around anyway. I'm not for that. So this is the tremolo module, and as I thought, there is a tube inside this. Now somebody's done some work before on this, because you can see here it's had some soldering done, and these caps are quite modern certainly compared to the others in here. So they'll probably be okay, and they look like the tremolo caps, and the trem works fine. So this is the switch that's really noisy that we've got to clean. You can see that resistor's been changed at some time. We've still got a couple of crusty old carbon comps there that are looking a bit sad and sorry for themselves. We've got a capacitor here which is 50 microfarad at 12 volts, so that'll be a cathode bypass cap, I would guess, on that one, I would guess. So we're going to change that, and then there's another capacitor here tucked down here, and I'm not sure what that's actually doing. You can see that black one there, so we're going to change that one as well. There's another capacitor there, look, just going in. You probably can't see, that's a Hunt's one. You can bet that one's tated. So we're just going to recap that basically, and then we're going to put it together. Right, so here's the data sheet that we've got. And the only thing we have to do with wiring this up, everything's the same. The pin 2 is the grid, pin 3 is the cathode, 4 and 5 heater, pin 6 is no connection as normal, same as an EL84. Pin 7 anode screen plate, sorry. The screen is now pin 8, where on an EL84 it's pin 9. So we move pin 9 to pin 8. And the suppressor grid is grid 3, is not internally connected in these tubes. So we will connect pin 9 to pin 3, and that's all we do. So we put a loop from pin 9 to pin 3, and pin 8 is the screen, simple as that. And if we look on here, we've got the usual, and the heater current is also much less on these tubes than it is on an EL84. We've got 450 milliamps. I think it's 780, is it, on an EL84? I'd have to check again. Maximum anode voltage 350, well, we'll be under that. 13.2 dissipation, 310 volts on the screen, so we just need some screen resistors to reduce that. And we're going to make these tubes work. These are brilliant tubes, very durable. Right, so we've got these wires coming out of here, and we need to put a ground across these chassis, and this is paramount for safety. Now, I weren't happy with these wires just willy-nilly floating about here, so I've put in a gland there, tightened those up, and now those can't move. So they just, and the thing with that is the ground then cannot be pulled out. So that's the way we've done that. So the next thing now is we have got to attach that ground to this chassis here. Now this is where things get a bit controversial. I need to drill a hole in this back to fit this ground, and I know there'll be some people saying vintage amp, you shouldn't be doing that. Well, two things going on there. One is this amp's already been painted. It's, you know, it's far from being an original vintage amp. This needs to be a working amplifier, but above all else it needs to be safe. This ground wire has got to be connected to this chassis. It is a must that this ground goes in there, and the tremolo unit also will need a ground. Technically the ground to the tremolo should also come from the amplifier, but I'm going to bring the ground for the tremolo unit from this second unit here, from this second chassis onto there. Because I'm bolting these so secure, we should be fine. But technically each ground should come from this unit here, but it's just getting more and more awkward to get cables through that hole. We just simply can't get another one through there, so we're going to have to do it this way. The grounding the chassis on the tremolo unit is even more important than grounding this. Most people will lean over the back to adjust the tremolo or to switch it off, and if they grab the case while they're still holding the guitar strings, that would be catastrophic with no ground on there. Right, there we go. We've got the ground in there. We've got this wire coming from the main chassis going onto there, and you can see I've cleaned the patina off so the metal's nice and shiny. We've got a star washer on there, and then this wire, which obviously has got to be trimmed to size yet, goes out, and that will be going to the trem unit. Right, so after much wrangling and messing around, we've managed to get these chassis back in. What a nightmare. Now you can hear that hum because it's actually running now. This amp was silent virtually once I'd got it right, but now I put it back in here, it's humming. And the reason it's humming, and you can tell exactly what it is because the volumes are turned down, and it's the AC switch. It's the AC feed wire here, and unfortunately that's what's causing that humming. It was worse. I've managed to move it further back, and that's about the best place I can get it. I hate AC switches. These are the problems you get on split chassis. It's just a common thing with them, really. You always get this AC hum. The way to combat that would be to put the switch on this chassis here, on this back plate, if there was room, and that would then get rid of that. But that's just something you have to live with, and it's very annoying. So just have a look some of the things I've done. So I've shortened these because these tubes are a little shorter, and so was the EZ80, so I've clipped and remade those. So we've got those sorted out. We've got one more to put on there. What else? That's the ground. So onto this ground. So now we've tested for this ground, and the way to test that these grounds are working okay is to pull the plug out and do a continuity test between the earth pin and the chassis. If you do that, before you do it, make sure you remove the screen, unplug these phonos, because these were the original grounds for it. So you need to remove these, otherwise you'll be getting false readings. You need to make sure that this ground, that if you fit these grounds like I've fitted them, that they actually work and they are grounding properly. And the only way to do that is to remove the phono plugs there to do that. So this amp is now safe. It's fully grounded. It's got the correct fuses in it. It didn't even have a fuse in it, did it? Only in the plug. So it's all looking good, except we've got to get this tremolo back in now. This is the last thing we've got to get in there. The tremolo works okay. This switch is still a little noisy, but we've cleaned it, not as bad as it was, because it had a bad ground on it in here. And what they've done when they replaced those capacitors, they just soldered it onto one of these rivets, and of course I was working on it, just fell off. So obviously that was a problem as well. So I've obviously I now have put this proper ground lug in there. We've soldered the ground that was loose to that, and we're away. So we're almost good to go with this, apart from, as I say, the disappointing is the hum in the background. That is really peeving me after all this work. And all these type of amps get that problem, all of them. Record players used to get them. Again, they used to have the switch, and it would be running, you know, because it wasn't on the actual chassis of the record player. They'd run the wires inside, and you'd get that hum. And there's nothing we can do. So you turn the volumes down, it's still there. It's AC hum. So I'm going to get this tremolo unit in there, and then we're going to have a bit of a listen to this on the speaker. Now this jack socket down here doesn't cut out that speaker, which is a bit naff really. Not sure what impedance that is. It's a bit naff, but we'll try it on this. We'll put an extension speaker in it anyway. This amp sounds phenomenal. I had a bit of a go of it on one of my 1B12 Marshall cabs, and it sounds awesome. But it doesn't sound so sparkling on that, but then it won't, will it? Right, I've got this Elpico ready for a demo. And it sounds pretty nifty on this speaker. I'm really surprised. So let's just have a look what we've got. We have got all the trebling on this speaker though, so it's not a very bright. It's okay. So nice clean tone out of that. Got all the bass in on there as well. Lean it over and just have a look at this tremolo. So there we go, that's the tremolo unit. Let's have a listen to it on the 4x12. Now we can't cut out this speaker, so we're just going to put this on 16 ohms and stick it through the cab, just have a listen, see what it's like. So we've got it through the 4x12, and you can hear now the AC humming from that switch, from that on-off switch. And this amp sounds gorgeous. Just take some bass off there. There we go, that sounds awesome. does. So those mods that we've done to make this better for guitar have really worked out well. It's just a shame about that AC hum from the main switch, but I'm afraid with split chassis it's a common problem. Been a bit of a long video this one, but we've had a few problems, but we've got there in the end. So yeah, the old Elpico lives again and should live for a good few years. So thanks for watching, you all take care, and I'll see you all in another video. Bye bye for now.